Hi, welcome back to Educator.com. This is the lesson on water resources and use. Alright, some water basics. This is about the molecule and how this water nourishes life and actually is perfect for us and our planet. It's somewhat of a review from biology, so if you recently took biology, a lot of this you already know. So some characteristics of water. Polar covalently bonded molecule. Oxygen. Two hydrogens at that little angle there. And it's polar because on this end of the molecule, it's more negatively charged than the positive side. So in a sense, oxygen is hogging the electrons a little bit more than the hydrogen is. So you end up having a polar as opposed to a non-polar covalent bond between the oxygen and each hydrogen atom. Though it's covalently bonded in a single water molecule, what keeps it bonded to neighboring water molecules is actually hydrogen bonds. And here they are right here. That's a hydrogen bond. That's a hydrogen bond. And you notice it's between the hydrogen of one and the oxygen of the neighboring one. The fact that it's the plus and minus allows for that attraction to form the hydrogen bond. When you're talking about the difference between solid water, ice, liquid water, and water vapor, the gas form, it's just a matter of how many hydrogen bonds are there and how many are being maintained in that instant. So if you have solid water, it's a heck of a lot of hydrogen bonds that are constantly there and keeping those water molecules spread out and in place in that solid form. If it's liquid, they're constantly being broke and reformed. That's why liquid takes the shape of whatever container it's in. And then, of course, gaseous water, the molecules are spinning all about. You don't really have the bonding going on there. So that's the hydrogen bonding there. High specific heat, what does that mean? In biology, I often use the example of the fact that when you're heating up water to boil it, to cook something, the metal of the pot that you're using feels hot faster than the water itself. That has a lot to do with water's ability to absorb heat even better than some metals. So how does the high specific heat help life? Well, the fact that water is able to store so much heat energy and able to transfer it as well has a big impact on the climate of a lot of areas on Earth. For instance, I live in Los Angeles and I'm close enough to the beach where it will probably never snow as long as I live in that area of Los Angeles. Not only is our altitude very low, close to sea level, and of course our latitude helps being slightly closer to the equator than some other areas, but the fact that the ocean is so close, it's not going to snow. If it rains, the temperature is not going to be low enough to make it snow. If I were to go 45 minutes north away from the ocean, yes, it does snow there during the winter. Universal solvent. Universal solvent, what does that mean? Well, it's really good at dissolving stuff. Chemical reactions happening in cells, chemical reactions happening in an aquatic environment. So, especially dissolving ionic compounds, right? If it has ionic bonds. So that ionic bond is between metals and nonmetals. So things like salt, sodium chloride, disassociate in water very easily. So thank you, water, for being a good universal solvent, the solvent of life. High surface tension, the ability of an insect to sit on top of water has a lot to do with the surface tension. Compared to other liquids, it has a much higher surface tension in terms of it kind of being slightly more stiff in terms of the waters kind of hugging next to each other. How does that help non-insect life? Well, the ability of water to move through small openings and end up being in certain containers in an effective way has a lot to do with the high surface tension. Related to that is cohesion and adhesion. Cohesion would be water molecules sticking to each other. So imagine water dripping down the windshield of a car. That's a cohesive property in terms of water molecules sticking to water molecules via hydrogen bonds. So the ability of water to go up the xylem of a plant has a lot to do with cohesion. It also has to do with adhesion, because adhesion is water sticking to surfaces that are next to it. The meniscus is the best example I can give you. Not the one in the knee, but meniscus in terms of like measuring water in a graduated cylinder. You'll have water inside, and if you look closely at the level where the water meets the air, it almost looks like a U shape where like the water is kind of almost trying to creep up the sides of the container, and they tell you to measure down there for an accurate reading, you know, at the bottom of that lip. But that's thanks to adhesion, so its ability to move through vessels has to do with that as well. The solid form is less dense than the liquid form. This is extremely important. There is no other liquid I know of that has that quality, where ice is actually less dense than liquid water. That's why ice floats on the surface of your glass as long as it's, you know, frozen and not melting. Well, as it melts, of course, it becomes liquid water. But this is why if you were to put a full glass of water in the freezer, it's going to end up having ice past the lip, right? The ice will end up taking up more space. It'll be less dense. That's important because if you think about all the glaciers and you know, polar ice caps, things like that, that are on the surface of the ocean, if ice didn't have that quality of floating on top, the Earth would be a very different place, and who knows what life would be like or what the circumstances would be related to that difference. Filters out harmful UV radiation. So some aquatic organisms or oceanic organisms can thank the fact that water prevents a lot of UV radiation from getting to them. Otherwise, maybe they would have genetic damage much more quickly due to that radiation exposure. Sunlight penetrates water to variable depths, so photosynthetic organisms can exist below the surface thanks to that quality. So those are some of the water basics that are important.